Hello Space Cats, I'm Dr. Maggie Liu and welcome back to my channel. In this week's video, we will be talking about black holes. What exactly happens when you fall into one? Can we even fall into one? Well, it turns out that what happens will depend a lot on the size of the black hole that we're dealing with. So let's start. A black hole is a region in space where the gravitational force is so strong that not even light can escape it. Stellar mass black holes, those with masses only a few times larger than our Sun, are believed to form when massive stars collapse at the end of their lives. But once a black hole is formed, it can continue to grow by absorbing mass from other stars, surrounding gas and dust, or even by merging with other black holes. They can then grow into supermassive black holes, those with millions of solar masses. It's believed that a supermassive black hole exists in the center of every galaxy. The closer you get to a black hole, the larger the gravitational influence, since gravitational force is proportional to 1 over the distance squared. Einstein taught us that time runs slower when you're in a stronger gravitational potential. It's called gravitational time dilation, and it means that for an observer watching from outside the black hole, the closer you get to the black hole, the more time slows down. The light is dimmed more and more and redshifted to longer and longer wavelengths until it's no longer visible. But in your perspective, time would be passing normally, and the universe outside would be on fast forward, evolving at high speeds until the end of the universe, at least if the black hole is charged and rotating. Such black holes are believed to contain wormholes, gateways to other points in space-time, other parts of the universe, or even different universes. But whether or not you make it out on the other side alive is another question. Just like how outgoing light of a black hole is redshifted, the incoming light is blue-shifted to UV, X-ray, gamma-ray wavelengths, and ever more energetic. This infinite blue shift of light would fry anyone falling into the black hole from hard radiation. If that hasn't scared you enough, for stellar mass black holes, the lower mass ones, the Schwarzschild radius, essentially the radius that defines the black hole, is much smaller than the Schwarzschild radius of a supermassive black hole. But this makes them even more lethal because they exhibit such stronger tidal forces beyond the event horizon, the boundary of no return. These tidal forces means that if you were to fall feet first into a black hole, the gravitational force pulling on your feet would be much stronger than the gravitational force pulling on your head. Gravitational force goes as 1 over distance squared, remember? So your body would be stretched vertically and your left side would be compressed to the right and your right side compressed to your left. You would be spaghettified. Our nearest black hole that we know of, QV Telescopy AB, lives in a triple star system 1,120 light years away from us. It would take us 1,120 years to get there if we were traveling at the speed of light. But it's still considered close, so close that we can see the star system with our naked eye. Well, at least if you live in the southern hemisphere. They seem to get all the best astronomical objects. Given that it's not likely we will ever get there, I think you can be pretty certain that you're never going to fall into a black hole. So just to summarize what happens when you fall into a black hole, well, it depends on the type of black hole, but you could be spaghettified and die, and if not, you may end up watching the whole universe die, be blasted with high energy radiation, and if that doesn't kill you, maybe you'll end up in an alternate universe. Thank you so much for watching this week's video. Let me know in the comment section below what you thought about it, and in the meanwhile, if you enjoyed the video, please don't forget to leave me a like, share and subscribe.